In this video, we will learn about the knapsack problem, how to solve the knapsack problem using the greedy method. So in the previous video, we have seen what is meant by greedy method. Okay, so from given n number of inputs, we are considering a subset of the n number of inputs. So how we are considering the subset? Based on some constraints. Okay, so that is the feasible solution, and from the obtained feasible solutions we are finding only one optimal solution. Okay, so here the knapsack is nothing but a bag. So we are considering a bag here that the capacity of the bag is 5 kgs. Okay, suppose you went to a market and you want to fill the bag with some vegetables. So you have to fill the vegetables to the bag such that it won't exceed this capacity. So if the number of vegetables in the market this bag exceed 5 kgs, then it can't handle. Okay, so the bag can't handle that vegetables. Right. So let us apply the greedy method to solve the knapsack problem. So we are given n number of objects and a knapsack. The object I has a profit Pi and weight Wi. The knapsack has a capacity M. So if a fraction xi 0 less than xi less than 1 of object I is placed into knapsack, then a profit of Pi xi is N. So we need to maximize the profit here. Okay, so we have some profits and weights. Suppose we went to a vegetable market, so each vegetable will be having its own weight and its cost. Right, suppose you are purchasing onions. So onions 1 kg is 30 rupees and tomatoes 1 kg is 20 rupees. Right, for each vegetable we have the cost and the weight. Okay, so we have to fill this bag such that it won't exceed the 5 kgs. So you can take any vegetable, but we need to fill the bag that such that it won't exceed this capacity. Right, so we are considering the fraction part here, xi 0 less than x less than 1. Okay, for each object that we are adding to the bag. The objective is to fill the knapsack that maximizes total profit earned. Since the knapsack capacity is M, we require total weight of all chosen objects to be at most M. So the capacity of the bag must be at most 5 kgs. So it should not exceed this 5 kgs. So xi is the fractional part of the object which is placed in the bag. So it must be between 0 to 1. That means it will be in the fraction. It can be either 0 or 1 or in the fractional part. Maximum profit is sum of the values I equals to 1 to n pi into xi. That is the fractional part, profit into the fractional part of the object. And capacity of the bag is sigma, the sum of I equals to 1 to n. So wi into xi, which is less than or equals to m. So the weight and the fraction part of the object must be less than or equals to the capacity of the bag. So m is the capacity of the bag. Okay, so let us see the algorithm of the knapsack problem. So here the algorithm is knapsack of m comma n. Okay, so p of 1 to n. So p is the profit, w is the weight, and objects ordered so that so p of I by w of I. So we need to find out the fraction of the profit by weight. So we are not directly adding the profit or weight to the bag. So we are adding the based on the fractional part of the profit and weight. So we are adding it to the bag. So m is knapsack size and x of 1 to n is a solution vector. For I equals to 1 to n, do x of I is equals to 0.0. So here u equals to m, that means we are assigning the knapsack size to the u. So u is the knapsack size. So I equals to 1 to n do. So if the weight is greater than knapsack size, that is the weight of the vegetable is greater than the bag size, then we will break the condition. Okay, and come out of the loop. Else, so we are going to consider the x of I, y equals to 1 to 0, 1.0, and u equals to u minus w of I. That means we're subtracting the weight of the vegetable from the bag capacity. So suppose if the bag capacity is 5 kgs and the weight of the vegetable is 1 kg, then we subtract the 5 minus 1 here. Okay. So if I less than or equals to n, then x of I equals to u by w of I. That means if the bag capacity is very small, so we need to find out the, so we are not going to add completely all vegetables into the bag. So we are going to add the fractional part of the vegetables to that bag. So here if there are fruits or vegetables or pulses, we can easily divide the we can divide the kg into half kg or 250 grams, or like we can divide that into multiple parts, right? If suppose there is a if there is a machine, then we can't divide it, right? So if there are vegetables, then we can divide it. So if suppose there is small space, then we will go to this condition. So we'll clearly see about how the knapsack problem will work through the example. So this is the example problem. So we're considering the number of objects here 1 to 7. So these are the objects that we're adding into the bag, and size of the bag is 15 kgs, and profits and weights. So profits are given here with P and weights, and profit by W, that is a profit by weight ratio this. Okay, profit by weight. So these values are profit by weight. So now we need to add the items to the bag. So we need to maximize the profit here and find the so if you maximize the profit, then we will find the optimal solution for this particular problem, and it must also satisfy the capacity of the bag. So the capacity of the bag is feasible, so it is the condition that we must satisfy. So it is a feasible condition. So every input must satisfy this condition, and we need to maximize the profit. If you maximize the profit, we will get the optimal solution. Okay, so capacity of the bag is weight into xi less than or equals to m. So we will go through these formulas later. So the total weight of the bag is 15 kgs. So we have to maximize the profit. So what is the maximum profit by weight ratio here? 6. So the weight of this one is 1. So 15 minus 1. So we are adding this value here. The fifth object we are adding into the knapsack. So that is equals to 14. So fifth one is added into the knapsack. Number 5 object. Okay. So later, so we will check what is the object with the maximized profit. So 5, right? So 5 is having the weight 2. So 14 minus 2, that is equals to 12. Okay. So now object 1 is also added to the knapsack. So now next, so we will check what is the next maximum value. So 4.5, right? So 4.5 weight is 4. So 12 minus 4 equals to 8. So we will add this one to the object 6 to the knapsack. So next 8 minus, what is the next maximum value here? So 3 and 3. So 3 is the next maximum value. Okay. So we can add any of this one. So I will add this one. 8 minus the weight is 5. So 8 minus 5 equals to 3. Okay. So next maximum value we have to search here. Okay. So next one is so 3. Again we are taking the 3. So the weight is 1. So 3 minus 1 equals to 2. Okay. So we are adding these two values here. Object so 3 and 7. So 3 and 7. So the remaining are so 1, right? So 1 and 1.3. So these are the two things remaining here. 2 and 4. Objects 2 and 4. Okay. So now we will check this. So here, if suppose I am taking the I have to maximize the profit, right? If suppose I am taking the 1.3 here, so then I need to subtract the weight 3 from 2, so which is not possible. So I am taking the fractional part of this object. So I am not taking the entire weight 3, so I am taking only some part of this weight. Suppose I am taking the 2 by 3 part of this one, so 2/3 part I am taking here. So 2 by 3 into 3 is so 2, right? So 2 minus 2, so that equals to 0. So we are taking only 2/3 part of this one. So the remaining thing we are taking the complete part, right? So 5, so object 5 we have taken completely, 6 we have taken completely, 7 we have taken completely, 1 we have taken completely here, and 3 also we have taken completely, and 4 we have not taken. The object 4 is not there in the knapsack, so this is 0, right? Object 2 is there, so object 4 is not there in the knapsack, so that's why it is 0. So this is called as the xi value or x value. So xi will be always in the form of 0 to 1, so 0 less than x less than 1. So it will be always in the 0, 1 or fractional part. Okay. So now we have added all the values into the knapsack. So after finding out this one, so we need to find the maximum profit and capacity of the bag. So what is the so first we will see the capacity of the bag. So after calculating the capacity of the bag, that is xi wi. Okay, so xi into wi less than or equals to m or not. So xi into wi means, so 1 into 2. So 1 into 2 plus 2 by 3 into 3 plus 1 into 5 plus 0 into 7 plus 1 into 1 plus 1 into 4 plus 1 into 1. Right. So the answer is, if you calculate this one, the answer will be 15. So similarly here, so after calculating the capacity of the bag, so capacity of the bag is less than or equals to m. So m value is 15, right? The capacity of the bag already given. So which satisfies this condition? So this condition is satisfied. So xi wi is less than or equals to m. So which is satisfied. That means the constraint is feasible here. Okay. So next we will see the maximum profit. So what is the maximum profit earned here? So maximum profit is the pi into xi. So sigma pi into xi. So what is the profit here? Profit is 1 into 10. So we have to multiply 1 into 10. So 1 into 10 plus 2 by 3 into 5 plus 1 into 15 plus 1 into 6 plus 1 into 18 plus 1 into 3. So that equals to 54.6. So this is the profit n here, maximum profit n. So this is the optimal solution for this problem. So this is about the how can we solve the knapsack problem. Thanks for watching my video.